Let's talk about direct variation. On a recent trip to the grocery store, Alan noticed the following chart next to his favorite brand of microwave meals. If you buy 3, the cost will be $6.75. When you buy 6, the cost is $13.50. And if you buy 12, the cost is $27. Well, always a person that's looking for a bargain, Alan noticed the highlighted row and the exclamation points, and he wondered if this meant that it was a good deal. So, breaking out his calculator, he divided each price by the quantity, and this allowed him to put a third column in the chart. If you buy 3, $6.75 divided by 3 means that each one is $2.25. When you buy 6 meals, $13.50 divided by 6 gives you $2.25 per meal. And then if you buy 12, $27 divided by 12 gives you $2.25 per meal. The exclamation points and the highlighting made no difference. No matter what quantity he buys, Alan will have to pay $2.25 for each meal. Because of this, we say that the cost varies directly with the quantity purchased. We can set up an equation to find our total cost this way. The total cost will equal $2.25, that's the price per meal, times however many meals we purchase. X is the total number of meals that you're purchasing. So the cost equals the price per meal times however many meals we're going to buy. Anytime that we have direct variation, an equation can be set up to represent the situation. Y equals Kx represents direct variation. K is the constant of variation. In the previous problem, our constant of variation was $2.25, the price per meal. Let's look at another example. For this one, the stretch in a loaded spring varies directly as the load it supports within the spring's elastic limit. A load of 8 kilograms stretches the spring 9.6 centimeters. Well, the first thing for us to notice is that it varies directly. The next thing we should see is that we're not going to let the spring break. We're going to do this within its elastic limit so that the spring doesn't break. Well, we know that varying directly, a load of 8 kilograms will make the spring stretch 9.6 centimeters. Since it's direct variation, y equals kx is how we can set up our equation. Y will represent how far we stretch. X is the load that we're putting on the spring. So we were told 9.6 centimeters was the stretch. Let's put that in for Y. We were told that the weight 8 kilograms is our load, so let's put that in for X. 9.6 is equal to K times 8. If we divide both sides by 8, we can find the constant of variation. For this particular problem, our constant of variation would be 1.2. Now we can write an equation about this particular spring with our constant of variation included. The amount of stretch that we have is equal to our constant of variation, 1.2, times whatever load we put on the spring. So now, what load would stretch the spring 6 centimeters? The stretch, that goes in for Y. So the stretch, 6, goes in for Y. Our constant of variation was 1.2, and we're trying to figure out what load we need to put in order for this 6 centimeter stretch to happen. If we take this equation and we divide both sides by 1.2, the constant of variation, it looks like 5 would be the result. So 5 kilograms is the load that we need to stretch our spring by 6 centimeters. When you've got direct variation, you can set up an equation, y is equal to kx, where K is the constant of variation. Dividing both sides will allow you to get K by itself and know what the constant of variation is to use in other problems.